Just keep it here.
Speed. Speed is very important in physics. To determine speed, you take the distance of the table divided by the time the ball takes to get across the table. As they're playing right here, Adam is going to spike the ball. Boom. You're able to determine the speed and how hard it is to hit the ball. With knowing the speed, you may be able to hit the ball back to the other side. Reaction time is very important in ping pong. To be able to hit the ball back, you need to have a quick reaction time. If your reaction time is slow, you'll not be able to hit the ball. And to find the reaction time, you multiply by the distance of the table by 2, then you divide by the acceleration of gravity, and finally you square root it. When your reaction time is fast, you'll be able to hit the ball back and you'll be a better ping pong player.
Go. Distance is very important when playing ping pong. The closer you are, the harder it is to hit the ping pong ball. But the farther you back away, the easier it is to nail it. As Matthew backs up, he's able to hit it more, and Adam and Matthew are able to play the game.
Take it.
The closer you play, the harder it is to hit the ball. But as Matthew backs up, the easier it is to hit it. And the table is 9 foot by 5 inches. As you can see, he's hitting it more, and it's not as hard, and he doesn't have to hit it as fast. Friction between the paddle and the ball is very important in ping pong. It allows the player to spin, hit the ball in any direction that he or she pleases to. Less friction means that they will lose control of the ball, and it will result in what just happened.
We dropped the ball.
As you can see, no friction at all.
Time is very important. To find time, you take the distance of the table divided by the speed of the ball. As you can see, the ball is moving very slow, and that way the time of the ball is make it very easy to hit. Now, when the time of the ball increases, like what Adam's about to do, like that, it's very hard. See, it's very hard to hit the ball to the other side. So time is very important, and it all depends on how you hit the ball and how hard you hit it.
Newton's first law says that an object at rest will stay at rest until an equal and opposite force acts upon it. As you can see, when Matt hits the ping pong ball and Adam hits it back, the ball will continue on this path until stopped, or another force hits it back.
Newton's second law states that the acceleration of an object is directly proportional to the object's mass. So if the object has a small force, it'll be small acceleration. And if it has a big force, it'll be large acceleration. So as Chad hits the ball softly right here, there's small acceleration. Now as he increases the speed, there's large acceleration. So to have big acceleration, it'd be a big force that helps in ping pong. Newton's third law states for every action force, there's an equal and opposite reaction force. This means that the amount of force that the ball applies on the paddle will apply the same amount of force on the ball. And so for the force of the ball to increase, the ball has to hit the paddle with a larger force, so the paddle will apply a larger force on the ball. Boom. Kinetic energy is energy in motion. Kinetic energy is the amount of energy that the ball has while it's traveling from one side of the table to the other. To find the kinetic energy of the ball, you multiply 0.5 times the mass of the ball times the speed of the ball squared. To have a higher kinetic energy, to increase the ball speed, you just increase the ball speed. And this will make the ball move better through the air and faster to the other side of the table. Kinetic energy is very important because it's what allows the ball to move. Without this, the ball would stand still and be in potential energy.